Welcome to a talk on small language models, where we explore how compact neural systems can deliver outsized impact. I'm Dr. Microlearning, and in the next few minutes we'll see why smaller, focused models matter. They compress knowledge, run close to users, and enable private, fast applications that large models alone can't achieve, especially at the edge or in regulated settings. This slide contrasts model compression, deployment, and trade-offs. Large models are distilled, pruned, and quantized down to millions or a few billion parameters, which reduces footprint and speeds inference. Those compact models can run on edge devices and modest GPUs, train faster, and preserve privacy offline, while trading some generality for sharper, domain-specific accuracy and fewer hallucinations. Here we walk through offline distillation. A large teacher model generates soft-label probabilities on curated domain data while ignoring noisy web text. Then a frozen teacher guides a compact student network to mimic outputs. The result keeps most of the teacher's quality, about 95% in practice, while shrinking the model size dramatically, making deployment practical on constrained hardware. This slide outlines efficient compression methods that work together. Magnitude pruning trims low-value weights with minimal gradient impact. Quantization converts 32-bit floats into 8-bit integers to save RAM and enable SIMD acceleration. And low-rank factorization breaks matrices into smaller factors to recover accuracy with light retraining, yielding roughly threefold speedups on typical edge chips when combined. Benchmarking balances accuracy and efficiency. Small language models in the 1-4 billion parameter range can reach around 90% of GPT-4's domain accuracy while delivering sub-50 millisecond inference on mobile CPUs. A 3B parameter sweet spot often gives the best trade-off between latency and quality, where quality gains taper and latency flattens, guiding hardware-friendly model selection for real-world use. Fine-tuning and on-device serving change the cost equation. A 3B model fine-tuned on 1 million tokens can be completed overnight on a single A100 GPU for modest cloud credits, keeping training cost and time low. Once deployed, SLMs consume mere milliwatts on device, shifting expenses from recurring API bills to one-time capital deployment and enabling offline, low-latency experiences. Local SLM deployment improves security and compliance by keeping sensitive prompts, health data, and financial queries on device or inside a factory gateway. This simplifies cross-border compliance like GDPR, reduces vendor lock-in, and enables efficient updates and audits because models can ship signed weights instead of raw data, streamlining breach notifications and regulatory reporting. For regulated domains like medicine and law, small models improve reliability and explainability by anchoring responses to vetted corpora and using retrieval-augmented generation, which drops hallucination rates below 2% in pilots. A smaller, more deterministic parameter space also enables attribution tracing and creates explainable reports that help auditors and regulators validate model behavior. Small language models have practical applications across industries. In factories and industrial IoT, they run on controllers to predict conveyor belt wear from vibration logs in real time. On mobile phones, they power offline multilingual voice translation for privacy and speed. And in automotive systems, they enable local vision language models for hazard detection when cloud connectivity is unavailable. This customer service case study shows business impact from a 2 billion parameter SLM fine-tuned on 50,000 historic tickets. It delivers ultra-low 200 millisecond response times and resolves 80% of tier-1 queries, resulting in roughly $500,000 in annual operational savings and a 35% reduction in agent workload while maintaining stable customer satisfaction. A pragmatic workflow takes you from scoping to edge deployment. Map task scope, data volume, and latency limits. Pick a distilled 1.4b checkpoint that fits your architecture, fine-tune efficiently with QLoRa using domain samples, then evaluate on realistic edge hardware while iterating quantization levels and battery budgets to reach the optimal balance for your target devices. Finally, hybrid AI routing offers a strategic path forward by sending simple, latency-sensitive requests to on-device SLMs and routing complex reasoning tasks to large cloud models. This hybrid approach balances cost efficiency, privacy preservation, and capability enhancement, and the actionable advice is clear. Begin integration and testing now to turn smaller models into everyday engineering tools rather than occasional luxuries.